This is the first time I'm actually speaking at the Papers We Love. I've been coming here on and off for a while, and then I just figured like last time I was here, actually it was in Houston when Justin Cormack was speaking about capability-based securities. I talked to him about this paper I came across about information-centric networking, and he was like, "Oh, you should definitely give a talk about this." And I'm like, "Okay." Not sure if anyone would be interested, but I sent an email to Renzo, and he was like, "Yeah, why not?" So has anyone ever heard of information-centric networking? Cool. No one. Okay, cool. Well, I'm just going to say first thing about something about me. So my name is Milos, like I said, as Renzo said. I work for a company called Micro. We're trying to like make microservices more accessible to developers. We have a microservices toolkit which you can use and just like spin services as much as you want. But this is just like part of the stuff we're building. We're actually building something way more complex, which I can't really speak too much about. But if you like building services or microservices, just come and talk to me. We're hiring. So that's my Twitter. If you want to follow me on Twitter, that's my GitHub. There's lots of like craft software. Half of it probably doesn't work anymore. I blog on that Cybernetes domain, and I also happen to organize Kubernetes London meetup, which happens to be on tomorrow night. But too bad you can't sign up because it's already like oversubscribed. But maybe you could show up and we can figure out something. Cool. So that's about me.
You should tell where it is tomorrow.
Where? It's exactly here, in this venue. Cool. So no one. So has anyone ever heard of information-centric networking? You have. Oh, awesome. So we have one person. I never heard of it until like a couple of months ago. From the paper. But before you read the paper. Yeah, that was exactly me like a couple of months ago. I was like, "Ooh, what is this thing?" Turns out there's lots of different networking architectures which are sort of like targeting different sort of specific semantics of network functioning. So this is just one of them. So why and how? I'm a subscriber, member of ACM. Is anyone here a member of ACM? Oh, awesome. Amazing. So I totally recommend it to people, like to be a subscriber. It's you get the access to like tremendous amount of like really valuable content from practitioners and researchers, and you also get access to over probably like 2 years ago after having already been a member for like 5-6 years. I was like, oh, I get access to O'Reilly books. That's amazing. But anyways, so so every now and then they send a newsletter around or like a blog post, the topics you subscribe to. And I'm subscribed to the topic about edge computing, which is becoming like, we're sort of like living in this time where we're sort of witnessing race to the edge. Everybody's trying to fight for the edge. Everybody wants to be on the edge, and I think it's kind of like, if you look at what companies like Fastly and Cloudflare are doing, and a lot of other companies which you've probably never even heard of, everybody wants to be on the edge to be more accessible to the client and to like developers and to the actual like physical life. So network is sort of like crawling into physical space finally, and edge is that interaction for us. So I came across this blog post about edge computing, and as I was browsing through it, as I was reading through it, I came across this concept called named data networks. And I was like, whoa, that's really interesting. So I started reading, and it had like all these references to information-centric networking, and I went down the rabbit hole of like reading white papers, and I discovered ICNs. I was like, oh, that's really interesting. And that's how I discovered the paper I want to talk about today. So why are we like talking about the ICNs? Why are they important? Like why and how? So as you can see that the internet growth hasn't stopped. It's sort of like flattened out, but it still keeps growing. But what's really interesting is the data volume keeps increasing. So we're just keep producing. This is nothing new to anyone, I hope, in this room. We just keep producing more data, and essentially like the internet is this like massive data production engine. And turns out somebody noticed this way earlier than we started noticing it. So these two like statistics, these are from the famous what's her name, Mary Meeker report. She publishes these reports about internet usage and all this stuff. So you can look it up on the internet. So it turns out in 2002, Brent Bacala is like one of the researchers. He noticed this and then he published this paper about data-oriented networking, where he says like web is actually like data-oriented. It's not really connection-oriented. He claims that the clients on the web are actually all about accessing the data and not about the communication, which is I mean very interesting and questionable. This is, mind you, this is in 2002. This is a couple of years before Google IPO'd and 2 years after 2002. Facebook was founded in 2004, I think, or 2007 or something like that. So this was before people started sharing more and more data on Facebook, and obviously like the curve of data production just like increased. So he made his statement and he published a paper about it, and it just goes on about things like, oh, look at the HTML. HTML was never designed for like things it's being used for now. Like, oh, now we have images, now we have graphical interfaces on HTML, and this is producing a lot of data, and that clients are accessing all these HTML-rich documents, and they essentially just pulling the data. So he made an assumption like internet is really data-oriented, not communication-oriented. So coming back to the whole origins of history of the ICN networking, there was a Brent Bacala with this paper talking about how data is important, more important than the communication. To some extent, you can question that. I do. Then that was followed up in 2006 by a paper called Data-Oriented Network Architecture, which sort of like built on top of it. Then in the same year, someone called Van Jacobson is a person I never heard of until I watched a talk he gave at Google about new way to look at networking. And that talk is actually like brilliant. Like I totally recommend it to you to watch it, because he goes through the history of like history of communication and like how we have evolved from the from telcos to like how the internet actually like came about, how it was built, and he makes the case for information-centric networking, and like he sort of like builds on the ideas which Brent Bacala introduced. Although I later found out that Van Jacobson was actually working on this concept like for much longer than Brent Bacala. Well, anyways, a couple of years later, Park announced the CCN project, which was content-centric network, which essentially like they published the specification of what content-centric networks should be. So you have a full spec, and they listed all these like benefits, and like if you comply with it, you're like CCN network. And they also open sourced one of the implementations. It is somewhere, and I couldn't find it. So I think it's probably somewhere like one of those like Stanford sites, and maybe it's on a GitHub. I just couldn't get hold of it. But anyways, I want to quickly talk about like what ICN actually is. So information-centric networks are new architecture paradigm. Turns out, by the way, as a side note, turns out that US have this thing called Future Internet Architecture thing, which is sort of like a foundation, which is funded by the National Science Foundation of USA or something, and you can submit a proposal about like what do you think the internet is going to look like in the future, and then you can get some funding. I had no idea until like a couple of months ago that there was a thing. So ICNs were sort of like, so one of the ICNs were born in a way that they just submitted it to a FIA. So coming back to the original topic, so information-centric networks. So they present like a new internet architecture paradigm where information, or named information, is at the core of it. So they sort of shift away from the host-centric network, which we are familiar with, to the information network. So think about like when you think about like TCP IP, whenever you want to talk to something, you have to establish a connection to the remote server. In information-centric network, that is sort of like flipped into the so the information becomes the core of the communication. So you don't talk to something, you ask the network for information, and it doesn't, like for you, it doesn't really matter where you get that information from, as long as that information is correct, and you can actually verify its validity and all these things. So this is like the major paradigm shift in what information-centric networks are about. So the information is named, and you access it by asking the network, as opposed to like particular, client, like particular remote server, bbc.com or whatever. Turns out, like, you take it to a whole other level. So some of the networks, as we'll talk later about, they even name the routers, or like all the network elements. They even name those, and then you sort of like route through those elements. So the expected benefits is like improved efficiency in data delivery, because every node in the network, according to specification, has to cache the data. So you have all the information is cached across the whole of network. Improved flexibility in a sense that so flexibility in the sense that when you have an IP address, you sort of like can't talk directly to some other points. When in information-centric networks, you sort of say, hey, I just want information, I don't really care. And then the way that information, or like the access to the information is implemented, it's basically like embedded in a network. So all you ask is like, I just want this piece of network information. So security is about basically asking for the network information and being able to verify that the information you asked for came from the originator, and it's actually like valid and it's correct, and it's like, data integrity check. You can verify the originator and all these things. Then there's like better scalability with respect to information demand. Basically, since every node has a cache in it, then you basically scale the amount of data much more. Because if you ask for a certain information and you can get it from like multiple nodes around, then obviously it's faster and it's like more scalable. And then a better robustness. If you think about like traditional networks, like we're looking at them right now, is even though there is an outage in the network, like in some router or like a network element, the request for your data, let's say you're accessing bbc.com, and then some of the network elements on the path to bbc.com have an outage. The network like sort of like figures out the route around, and you can always get, your packet will always get routed to the final destination. The problem with that is, what if the bbc.com is down? So you basically have to like back up the data and all these like hassle around it. The information-centric networks sort of like approach it from the first perspective, where you want the data. It's like, I want the bbc.com article about this, and then nodes, like whichever node has that information will give it to you. So you're no longer relying on the end destination. So network literally serves the information to you as opposed to like endpoints. So that sort of is supposed to be like improve the robustness of a network, in theory, of course. Anyways, so that was just like an introduction, like sort of like what the ICN is, and this is the paper which I want to talk about today, which is sort of listing like various networks, like critique where they should like focus more, what's wrong with them, sort of like highlight deficiencies of different designs. Mind you, this paper was published in 2010, which was 9 years ago. And that's kind of interesting because the access to information and like all these like data caching, all this stuff, it was a big topic back then, because Netflix wasn't really a thing in 2009, 2010. Netflix was still sending around DVDs. So you were like, okay, we can't really stream Netflix. I don't know, when did Netflix started streaming data? Was it like 2015 or something? Something around that. So the authors of the papers, they said, there's a lot of literature about like different information-centric networks, architectures, and there's like it's very hard to make sense of all of that information. They try to summarize it and like make it more accessible to people. So basically, there is several ICN networks. There was a lot of ICN networks at the time the paper was written, because everybody was sort of like trying to address the problem of making the data more accessible, faster, and like more scalable in some sense. And then the paper like lists various approaches. Like it mentions the Brent Bacala paper, which I mentioned at the beginning, and then the data-oriented network architecture, which sort of like build on Brent Bacala's ideas of like clients wanting the data as opposed to like communicating to the host, which should be returning the data to them. Finally, there was a design. There was as I mentioned, the CCN, which provided specification for ICNs, which also provided like an implementation of ICN. And then Van Jacobson, the gentleman who gave a talk at Google about the new way of thinking about networking, which I mentioned earlier, he created one of the implementations called NDN, which is named data network, which sort of like implements all these ideas defined in CCN and builds on top of them. So there's a lot of commonalities between them, and that sort of confuses. At the time, it confused for reading these papers because all these papers apparently were focusing on the mechanism, but it turns out a lot of mechanisms which were in those papers were actually very similar to all those networks, and that confused a lot of people. So this paper is basically trying to summarize what they're all about. So there are some basic primitives which are similar for all the networks, and they're built on top of publish and subscribe, where clients come, they show up, they subscribe to certain kind of information, and then the content providers publish that information, which clients then can fetch. And there are some differences between what the clients can fetch, and there's what I find interesting. I was browsing through like various different like ICN papers, and I really enjoy the creativity of the designers in terms of like names and verbs they came up with, describing the same thing. So some of them like talk about like register an interest, some of them like request for information, and it's basically like all, as the authors like of this paper highlight, it's all about the same concept, which is publish and subscribe. But the creativity the authors came up is just to differentiate from other network designs. It was like, wow, this is really something. So the basic paradigms is based on publish and subscribe with like some small semantic differences. But there's a difference between traditional publish and subscribe, which is in a traditional way we think about it like you subscribe to the topic and you come and then keep retrieving the information on the topic continuously. ICNs define also like one-off subscriptions. So you just come and grab it and never come back. So this is like a tiny little bit different. But another thing is like which I mentioned, like universal caching, which is essentially absolutely important in the design of the information-centric networks, because what the networks, what the ICNs are trying to address is to make data more accessible and much faster. So the caching is at the core of the network. Each node in the network provides a caching, and what is the next one? And the content-oriented security model, which is really interesting, because when you come to the network, you have to essentially know what piece of data you want to access. So you come to the network and you say, Microsoft, I want this video from this date, and then the network sort of like figures it out. But here's the thing: how do you know that whatever you get back from the network actually is what you asked for? So this is a really interesting point about ICNs, that the security model in ICNs, because of the nature of the network the ICN is, which is data-oriented, sort of shifts away from securing the path, which is the communication. Like in our case, like when we want to talk to a server and ask for content, you establish the TLS connection. There's like a handshake and all this stuff. Okay, I see a certificate and all this stuff. So we are securing the path. ICNs are securing the data, which means every chunk of the data which is served by a network can be verified using a public key or some kind of like PKI infrastructure. So you fetch the block of data, and then you just like check it. Oh yeah, this is good. So this is valid. So this is that shift between like host-centric network and information-centric. Instead of securing the path, you're securing the actual data.
I'm not sure I understood what exactly they mean by those concepts, because it's like the data model is very vague. Like what is actually being published, what is being subscribed.
Yes. So as a client comes to so think about it as like literally like a news delivery. So your subscriber, or even like RSS. This is literally almost like RSS. You subscribe to a topic of some name. Let's say, I'm interested in cars. So you show up, I'm interested in cars, and then the publisher shows up and publishes some data about the cars, and you fetch the data. So this is what they mean by pops up. So it's not really like, when we think about pops up, it's like, oh, I'm just going to subscribe to this like queue, and then somebody just come, and I'm just come and pick it up. So you literally like, you subscribe the interest in a certain piece of data, certain piece of information. Okay. And then you have a content providers, which is the network, which serves the data to you.
Content providers, they change the content of the news article. Is this stays under the same data name, or is this a new article now?
That's a very good point, and I think, like, I didn't think of this, but this is a very good point, and I believe the way, the way you access information in information-centric networks is via name. When it changes the sort of like content, its SHA changes. So it's sort of like, its checksum changes. So as I mentioned, like in a security sort of model, you always have a public key, which allows you to verify the integrity and the originator of the piece of data. So that changes, and it's sort of like, but if you're asking if you get notified that article is changed or not, I'm not really sure. So if your question was sort of like about what if the data gets modified, and do I get like notified about it or something?
Yeah, like is the data model being care of those named data resources that are mutable, that can be changed by the publisher, and subscriber gets some version that was published in the past, then there is a question.
There is a way. So basically, so a lot of these ICNs. So later I'll talk a little bit about like the way the data is being accessed, but it's being accessed as ICNs serve named data, and the naming structure is hierarchical. So the way, I guess, the way I'm imagining it, and I'm not sure because the article doesn't really deal with like how it deals, so it doesn't mention how it deals with version data. So what I'm imagining is it just adds the new node to the tree. So basically it'll be like car/1, car/2, and then you'll be like, you essentially just trees out, because as I will talk about it later, the information accessibility is hierarchical. So you essentially just traverse the tree. So it's a great question. To be honest, this is how I'm imagining it. I'm not really sure. Cool. So those were like commonalities. So first was about pops up. The second one was what did we do? Oh yeah, universal caching, and then the security sort of flipped from securing the path to securing the actual like blocks of data. And then there's a lot of fundamental differences between networks. The first one is the naming, which is what we literally just discussed. Because when you're accessing the data in a network, you must know the name. You literally must know the name of the information. You have to say, hey, I want the information about car, and then you sort of like networks. Okay, this is all the information about cars I have. So you also need to know, because of the security model, you also need to know content provider's public key, so we can verify the integrity and the correctness of the data. And one of the things which is really interesting about this is the denial of service attack is also like defined in a different way than what we're like sort of familiar with. When we think about like denial of service attack in our host-centric networks, we always think about like, okay, when somebody is just like making this service inaccessible, whatever the service is. In a sense of ICNs, it's sort of like, can this network serve the data verifiable by a public key? Because if it can't, then somebody is messing with that network, with the data sort of content. Because the data is literally the core of the network itself. If the data which is being served to you is wrong, then that's essentially like a content as a false content, as a denial of service attack. So there were like there's two main naming systems proposed in the literature. First one is very similar to DNS, which is sort of like hierarchical. So where you have some kind of like delimiter between the names, and they define the relation of the information you're trying to you query. So some of the networks I noticed they use dots, some of them use slashes, and there's like the creativity we'll find in these papers is just like, wow, this is just amazing. So that's one of them, but you also need to find a way how to bind the name to the key. So that requires sort of like having a PKI infrastructure, public key infrastructure somewhere available. And that also like sort of puts sort of like burden on the operators and on the network itself, because then you need to go and query the PKI for all this stuff. So it's kind of like, yeah, some networks do this, some others choose a different naming convention, which is called self-certifying names, where the public key is actually embedded into the name of the host. But it's superior to the other one because it doesn't require PKI. So you don't have to like rely on some kind of like PKI infrastructure as a source of trust. Instead, you chuck that public key into the name and it becomes part of the name. So you have a name and you can use that name to verify the originator of the content. Has any one of you ever heard of IPFS? So, have you ever seen the IPFS names? I was like, what is this craziness? Up until I read this paper, I was like, that's why. Because then IPFS is basically like some kind of decentralized network which serves data. You can use it like to build decentralized CDNs and all kind of stuff. But if you look at the names of the data you want to access, they look like, what am I accessing? Is it like pictures of cats or like, what is it? So this is exactly that those pieces of data. Yes, question?
But you do need a root of trust, right? How do you know that a public key belongs to a specific?
Exactly. Web of trust. Yes. Basically, yes. Yeah, you need to build like a web of trust. Yeah. So that's sort of like the self-certifying name sort of like pushes that into sort of like the decentralization of the realm, where you build that like web of trust. So that's a very good point. Yeah. So there is a difference between like PKI, which is sort of like centralized approach to like validity, and then the self-certifying names, which are built on a web of trust. So those are the two differences. This one was chosen by the authors as superior because it gives like a performance, like faster performance, and also another thing you need is like you need some kind of like gateway which translates the name data into actual, chunks of data. Because for example, classic example is the IPFS. So if I want to access something on IPFS, I have this like crazy like checksum. It's just a crazy hash which I need to enter there. But then it gets, you can run this like IPFS name service, which sort of like translates human readable names into those like hash sums, and then you can access like IPFS network on that. If you ever have you ever heard of like Cloudflare is running IPFS gateway? And they sort of like, they allow you to build your own CDN on top of Cloudflare, or like they will allow you to like store your IPFS data on their network, and they host the IPFS gateway for you. So anyways, the self-certifying names, they require a web of trust. They are also like human unreadable, which is kind of like annoying, but And yeah, the other one requires the PKI, but it's hierarchical. And then the other fundamental difference is the inter-domain name-based routing. So basically, like how do you route the request between different networks, different name data networks? So there's different approaches. Like some of them like borrow stuff from BGP. Some of them like there's name data network, which is one of the implementations of ICN. Implements its own routing protocol, which I mentioned like earlier. They even named routers, and every single element of the network has its own name, and it's like a whole thing. You can read about it in the NDN paper, and I'm like, whoa, this is kind of cool, but kind of crazy. And then there is a discussion like what is the narrow waist of the network. In the host-centric networks, it's the IP, Internet Protocol, which is the fundamental part of the networking, because without IP on a host-centric network, you can't literally do anything. If you think about what you need to do in order to actually like access anything on a host-centric network is like, if I plug in my laptop somewhere and I have DHCP enabled, then I go there and just like broadcast on the broadcast domain. I was like, hey, I want an IP address, and there's a DHCP server. It's like, hey, try this, and I'm going to configure the whole network stack. I was like, oh, finally, I got my IP address, and then I get to talk to something. So without the IP address, you can't do anything. So in the host-centric networks is the IP, and there is a big discussion about like where is that narrow waist in different kind of ICNs, and the authors argue that it's kind of like not that relevant to the core of like the functioning of the network or the performance. So they say like it's orthogonal. Oh, great! I managed to say it to ICN design. So it's like one of those philosophical things. Like, is this the narrow waist, or can it be pushed down if we build on top of IP, or like if we build below an IP? If we build on top of IP, then obviously IP remains to be in the narrow waist. So it's like different papers, different networks define like, okay, no, this is our narrow waist because of these properties. This is our narrow waist because of these properties. So it's like the authors of these papers are like, maybe you should think about it a different way. But there's a lot of things which, according to the authors of the paper, require attention. So the topics which deserve less attention, according to the authors, is like providing the caching, because they argue that HTTP is like well equipped right now. At the same time, we can also like provide caching using various different caching servers, which we can already deploy. So they sort of argue that if you're focusing on caching, that part of like a network design has already been solved by the internet, and they argue that like if there is one thing the internet like does right now very well, that's delivering the data via HTTP. Topics deserving more attention: privacy. So when you're accessing the data on the ICN, you essentially like throwing your request on the ICN, and that request contains the name of the information you're requesting from the network. You're hitting some nodes, and then if that information is not available on the node you happen to be like hitting it first, then that sort of like gets routed to whichever node actually serves it. What's really interesting though, like in this sort of like model where the security is shifted from securing the path to securing the actual chunks of data, that means whoever has access to the network can actually see what data is being served. When you secure the communication in a host-centric network, all the data you're requesting from a network is being encrypted right now. So nobody can see what kind of data you're actually reading from the remote server. Whilst in the case of ICNs, you request that data can come from different nodes, and then you have the public key, and you can verify, okay, this piece of data came from this originator. So you sort of like, if you have access to those nodes, and if you see what nodes serve what kind of information, you can sort of like piece together the knowledge about what information client was requesting. So the authors are arguing like the privacy definitely deserves a bit more attention than it's getting right now. And then there is a topic of scaling the object sizes and the narrow waist. Again, we're back to the narrow waist. There is different arguments like by different ICNs. But the point of it is like, if you want to operate ICN, you need to be serving the data on a packet speeds. So what I mean by that is, if you're requesting a certain kind of data and your network is limited on a lower level of the data link by like the bandwidth, like the speed of it can serve the data to you, and if the request for the data, resolution for the request for the data takes much longer than the serving of the data, then maybe there is something wrong with the design of the network. And this is like one of the things that I question. Like this is one of the things which needs to be addressed by a lot of these ICNs. What I mean by that, like let's say I request about a car. So what I have to do is I need to send a request to the ICN, to the network. Hey, I want some information about car. Now the network receives that request and is like, okay, we need to find where that piece of data is, in the network so that we can serve it back. So there's different ways you can look up this information, which is like you can either do like some kind of like crazy request lookups, or you can like offload that lookup to some kind of like scale out server, which also obviously like slows down the request lookup, which also has an adverse effect on serving the data. So the authors are arguing like if those lookups take a long time, and mind you, like since the information is often like organized in a hierarchical fashion, and if you can't like traverse and like look up that information, that's sort of like makes the ICN much slower than its initial promises. So if you think about like how we're doing DNS queries, if your DNS lookup is very slow, like in the host-centric network, then you're kind of screwed. It's like this is your bottleneck. It's like unless you know like direct IP and you got all these like paths and all this stuff, and you send the right headers. So this is the same with the name request. If I go to the network and say like, I want a car, and then if it takes a long time for the ICN network to look up where the information about car is, that's the bottleneck. So you need to make. So the authors are arguing like those lookups have to be like made much faster in order for the network to serve its purpose. And then finally, this is kind of interesting because the authors of this paper like clearly they decided like, okay, we're gonna look at this whole paradigm shift like properly, and they sort of like ended up focusing on the caching part of it. They focus like, okay, this ICN is actually like trying to solve a problem of data caching, which is a kind of thing which a lot of people were solving up until this point, because we're in this like 2010, and I was like, there's more and more clients coming to the internet, and they're like more data hungry. So there's been like there was a lot of research at the time dedicated to figuring out how to cache the data properly. So you would have all these like new CDNs coming alive, like Akamai and whatnot, and they all come up with these like different ways of doing caching and distributed caching and kind of stuff. And one of those ways was a concept called cooperative caching. So you request data on a host-centric network, and if it's not finding that cache, then the cache queries other cache, and then other cache queries other cache until everybody's tired and it times out. So the authors are claiming like, and at the very fundamental level, ICN seems like it's trying to solve a problem of distributed caching or cooperative caching. And the authors are like finishing on all that like, listen, like this problem can be solved already very well. So I'm not really sure what you guys are trying to like come up with. So they are literally like ripping into it, and they also make a claim that the data on the internet is distributed using the ZipF distribution, which essentially means that there is a large amount of data, or like a smaller amount of data, which is more demanded than large amounts of data, and that data is basically cached by CDN very well. And this is they also like mention like how Facebook engineering are doing this. They claim that so Facebook have a multi-layer caching system. So they have their own CDN, then they have their on-host cache, and then they have obviously Drive. They say if the request don't like if they miss the cache in CDN, Facebook never end up caching it on a host, because they can hit, then it just makes, CDN. Then it doesn't really make any sense for them to host it, because they know that the data is actually not being requested that often. So the authors are saying like, I really like the sentence where they say, changing the exponentially growing world of content with the logarithmic sort of caching seems a classical example of taking a knife to a gunfight. It may make for a great story, but it won't end well. This sentence is like, it just really cracked me up. But I think honestly, on a fundamental level, I think the authors of the paper are sort of like missing the whole point of it. They make a lot of valid points. They say, okay, since the caching is at the core of the network, since every node like is providing the cache and all of these things, they make a valid point that it's also ICN sort of like provide this like new paradigm of like turning the internet into the like massive caching network. But I think like the actual authors of all these ICN networks are thinking a bit differently about this. They think about like network management, IP management, and all the operational side of things, as opposed to like, hey, I'm just going to have this node, it's going to join, and it's just going to cache these things. So the authors are saying like, maybe all these, they're basically claiming there's a lot of benefits in ICN design. There's lots of research going into them, or there was at the time. But they're asking like, should we really be focusing on these things to achieve the small amount of benefits we have achieved so far? I don't know. It's a very good question, but I feel like the authors of the papers are sort of like missing the point. But at the same time, their questions are quite valid. Anyways, that's it for me. Questions?
Isn't it very similar with peer-to-peer networks, right?
Yeah, exactly. Yeah. So this is exactly very similar to IPFS. So like I mentioned IPFS, which is sort of like peer-to-peer network as well. But there is a difference in BitTorrent where you just chuck a lot of data, but you can't really verify the originator because you don't have access to public key. It's like you download a bunch of data and you're like, okay, what is this data? It's like pictures of cat. Nobody knows. But yeah, you're absolutely right. So IPFS is sort of very similar to BitTorrent as well. It's a peer-to-peer network, but in IPFS, it's just kind of interesting because I don't think IPFS present themselves to be information-centric network. But as I was reading through and researching through all these papers, I realized actually like maybe it is. So no, but this is an excellent point. Yeah. Yeah.
You need some mechanism for distributing the public keys.
Yeah. You need to build a yeah. But is there any provider of BitTorrent which allows you to do that?
I'm not aware of any.
Yeah.
I know the system that.
Because I know of some companies. I sort of like worked for some company like in past as a freelancer, and they were developing private BitTorrent. And it had some of those things embedded. When you create a new client, you were actually like generated key, and you could like download the public keys of all the participants in the network, and then you could verify that. Which was kind of like, I was like, well, this is a private BitTorrent where you sort of like trust the peers in the network. So like, it was kind of unnecessary, but it was like they wanted to sell it to enterprises. Then I was like, yeah, enterprises need those features. I'm like, fair enough.
I know that there are systems for public key management.
Yeah.
Like Keybase.
Yeah. I use Keybase. Yeah. Ah, that's a good point, actually. Yeah. The thing is, like with ICNs, so when I was researching this, I came across like so many implementations, but it looks like very few actually survived, besides the NDN one, which is the Name Data Network, which is maintained by this Van Jacobson guy, who apparently was working on this thing. He has been working on this like for decades. This is the guy who gave a talk at Google, and I really do recommend it. Like, if you, for example, have any time, like spare free time, just like watch it on like a speed, replay. He goes through the history, and he's like, it's a fascinating character, he's special. And he was at NBC, for example, in, what was it, like Salt Lake City? Was it the Olympics, Winter Olympics? like Americans have had this skier there, Bobby Miller, and when he was skiing down the slopes, like everybody was like watching that, and NBC were streaming the live coverage, and he was working I think at NBC, and he was like, so I'm there at NBC, and I'm looking at this like network, and it's just getting congested, and I'm like, why is this happening? And he realized like, when I looked at it, we realized that we're serving the same data to like thousands of clients. So like, why do we have to do this? Why can't we just serve one stream, sort of like broadcast it, and then the client just pick it up? And he was like, why isn't like multicast and anycast? Why isn't it part of like of the network itself? Because you essentially like in a host-centric network, you would have like 20 clients, and they all connect to this server, and it's the same stream. It's literally like so wasteful. So he was like, so I was like, oh yeah. We had this like name data networking, and then we can actually do this like broadcasting where a server broadcasts this data to all of its subscribers, and then subscribers just like fetch the data from various nodes and just assemble it. So this is like, and he's like, if you watch the talk, it's really fascinating. He goes like through the history of internet all the way from 70s all the way to now. Yeah. No, the thing is like what he says in that talk he gave. He actually uses radio as an analogy. It's like, why don't we just have a radio on the internet? Just like, but then again, like he's like a researcher.
It's striking that this discussion there's slightly past the point of this paper, if I understand right. Because I think what they are saying, if I understand what you're saying, what I've been reading correctly, is that this idea of ICN has to have all of those parts together, or it's nothing, isn't valid, but that these three key design ideas can kind of be developed independently.
Yes.
So, and can be switched out for each other, so you can build the naming, the idea of naming and content-based security on top of routing protocol like Victoria. Or you can take a universal caching approach.
It can be any transport, yeah.
Not have named,
yeah.
Not have the named data, right? And I think part of the question that they're asking is, what's the right combination? What are the things that are actually valuable in this, and what are the things that are not valuable?
Yeah.
Maybe they seem to be saying that the universal caching thing maybe isn't quite the most useful thing, but the other bits actually have some value.
Yeah, that's exactly yeah.
Look at how we can get those on other architectures, and so things like
the data security is there.
Like Dataoriented, etc., are in some ways perhaps continuations of that development, of some different aspects of that.
I genuinely feel like when I discovered IPFS and when I sort of like revisited it again, I feel like they're probably like the closest to what I imagine it.
They basically have shards from that.
Exactly, yeah.
Right? And that's, they basically have named data.
Yeah.
They don't do universal caching.
Yeah, they don't do universal caching.
But basically, which these guys seem to be saying is a good thing to do.
Yeah. They say like, do we really need to invest in that much effort into that when we can already like handle it in a different way?
They don't necessarily have a PKI connected to it, so you don't necessarily have.
Because they use the self-certifying names that.
But that doesn't necessarily still. I mean, that's a shard of the content, but it doesn't necessarily tell you who it's from.
Yeah, that's a good point, actually.
Right?
Doesn't it?
So it tells you.
Yeah, you literally have to run like some sort of like a name service daemon, which sort of translates between the name into shards of the pieces of data.
That's right. So it's basically just a shortened form of the contents, right?
They do the checksums, yes. Of actually, yeah, they don't actually like embed the public key in the name. Yeah. That's a good point.
You could do that on top of that, right?
Yeah, you could do that. Yeah.
Separate PKI and embed the key.
This was the argument. Is sort of like.
And then get back.
This was sort of the argument they were saying like, there is a lot of discussion. Where is that the waste of the network? Like, is it there? It's like if all these like components like. Are designed in a way that you can swap them, and you can like sort of push that waste all the way down. It's like.
Question, like how far
that from an existing code? Would it be on top of TCP, on top of HTTP?
That's a very interesting point, yeah. I believe the NDN has some kind of like, it's built on top of TCP IP. But it has some kind of like, actually, you know what? So this is what happens when you have those, how do you call them, hot corners in, always bites me. See, this thing here, I don't know, can we make it bigger? So here's the IP, UDP, P2P, broadcast, whatever. This is the physical layer, and these are the content chunks. So this is I guess essentially yes, yeah. But it's really interesting. Like when we talked about the naming of the things. You can see here, this is sort of like the way, so what they're claiming is like, so NDN names are sort of like opaque to the network. They're like the delimiters are sort of like creating a relationship between them. So NDNs use slashes. So you can basically request this. But what's really interesting here is how do you access dynamically created content? Like let's say, because if you think about it, like when you have a static content, you just like cache it somewhere, you generate some checksum, or you assign it, and you can just verify it. The way they do it, like you sort of like embed it into the network in a way that the network knows how to how to sort of like verify the dynamic content, which is, so they have this example of like when the consumer just requests some kind of like piece of video, and then it receives some packets and then just like keeps on incrementing. There's kind of like a funny way of going about this. There's someone actually who built a video conferencing program using NDN. And the video conferencing is essentially like a dynamic data. So they have this concept of selectors, and the nomenclatures in all these things is so creative. It's like it's so fascinating.
Or rather, in something not reinvented.
But in a different way. Yeah.
But that's kind of what REST tries to do, right? Is to go, here's a nomenclature for giving names to pieces of data out there that you may not have seen before.
Yeah. In some sense, yeah, I see what you mean. But the whole thing is like, it's the whole routing stuff and all kind of stuff. So in the end, they take it to a whole other level. Mind you, this is arguably like probably the concrete implementation of ICN, which is still going on, which is still being actively worked on. I think I might have it somewhere. They even have hackathons and everything. It's like it's amazing. Ah, see, they even have a newsletter. And there is actually like, so I found a few implementation of this. Like they have a sandbox you can play with. I couldn't get it working, but Codebase. And I found a couple of like implementations. One, they do this. The routing in NDN is done based on path, as you saw. Like you have slashes, which sort of like define the relationship of the data you're asking for, And it's really like they don't really care. It's just they just match on the deep path, deepest path they call it, something like that. Yeah, there's implementations in different languages. There's a Python one, C++, in JS. Yeah, I'm not sure. Does anyone think like this is practical in any sort of way? It's a fascinating way to think about a different architecture of the internet, but I was thinking like, what, this is exactly, yeah. So that's the thing, like the benefits they are claiming here, which I mentioned here at the beginning, is like, in theory, you get better security. So it's like, will security convince people? Like robustness, for example, like you don't have to rely that your server is always on, because like if it in a host-centric network is like that server has to be on in order for the data to be served.
That's only true if your data is static. Right?
Exactly.
If it's dynamic, you still have to have that server that's doing something. Yeah, because even if all the caches were doing it, expire caches when you need to.
So yeah, that the way this works is let's say you have like multiple nodes on the network, and you ask for data, and if that node doesn't have the data, it asks other nodes on the network, and then it returns it back. So if it finds it somewhere, and on its path as it serves it back, it caches the data it was requested. So that sort of like improves like accessibility and the demand propagation and scalability and all these things. So. What's really interesting, what's really funny about this whole concept of information-centric networks, like, there's this well-known joke about what's the hardest problem in computer science, right? There's naming things and caching. They're like, hello. These folks just like decided, like, why don't we just tackle this hardest problem in computer science? Named information and caching it.
Maybe like semantic-based with something deeper, with deeper representation.
That's a very interesting point, actually. You mean like the network will become the AGI?
Like a memory, like a memory of this.
Yeah. Because I mean, the NDN implementation demonstrated that it can serve the dynamic data. This is what the Van Jacobson was talking about. It's like, we were streaming this data and it was going through like multiple clients at the same time. It's like, what a waste of bandwidth. So it doesn't have to be like a static data. Doesn't have like, if you can make it on dynamic data, then if the network sort of like constantly like sort of develops like new things and you ask for that stuff, it's a good point actually. That's a very interesting insight. I didn't think about it that way. Yes. Thank you.